Hey guys, we are looking at problem 5, a refrigerator. So for refrigerator in this chapter, as I mentioned, we always draw the 3-block diagram. So refrigerator, the blocks. So you will put the refrigerator here. Then this is a higher temperature. This is a lower temperature. So how the refrigerator works, you have work input, which you plug the refrigerator into the wall, electricity going in, that's electric work. So the purpose of the refrigerator is to extract QL from lower temperature. So QL is your desired. I put the check mark here. Then you extract heat from your food, which is lower temperature in the refrigerator chamber. Then you release the QH to higher temperature, which is your kitchen air. So that's how a three-block diagram looks like. When you try to solve a problem, always start with the 3-block diagram. That's very simple and easy for you to follow up. So let's look at this. Our refrigerator consumes 400 kilowatts. So this is 400 kilowatts. During normal operation, COP for refrigerator, COP is desired, it's QL divided by input work. So you have QL divided by 400 equals 2.7. This is a COP. So your QL will be, if you do the calculation, will be equals to 1080 kilowatts, 400 times 2.7. So let's continue. So the question is to ask you at what pressure must the evaporator operate to remove the appropriate amount of heat. Refrigerant R134 is used. The fluid goes from saturated liquid to saturated vapor in the evaporator at a rate of 5 kilograms. So in the evaporator, where is the evaporator? Evaporator is attached to the food chamber, right? So that means the evaporator is going to absorb QL. So basically here, the evaporator chamber is around this area. It's at your TL. It's close to your lower temperature chamber, because that's your food chamber. So here, basically, what you are doing, you are the food, the saturated liquid. What happening here is saturated liquid become saturated vapor. So the heat going in is your QL, because your food release QL, the amount of heat of QL and the heat is absorbed by the R134. So after reabsorbing the heat of QL, the R134 become saturated vapor from saturated liquid. So basically your QL will equals to the mass of the fluid times the energy, like the change from saturated, the energy change from saturated liquid to saturated vapor. So the QL will be equals Hg minus Hf, which is HFG. So here equals HFG. So your mass fluid is 5 kilogram per second. So your HFG will be equals to 1080 divided by 5, which is around 216 kilojoules per kilogram. So now you are going to go to your table A12. You want to find the pressure. So in your table A12, you will say you have the pressure. You will have the pressure column. Then you will have a column, like there's other columns in between. You have HFG column. So now you will do the interpolation again. So you will find HFG. It's between 100 kilopascal and 120 kilopascal. Oh wait, equals 120 kilopascal. So at 100 kilopascal, you have 217 1.19. That's your HFG. And 120, you have 214.52. So this number is in between. So you can do the interpolation to find your pressure, which is 108.7 kilopascal. That's the problem. So the only part I think it's deep or maybe difficult for you to comprehend is the QL. Why QL equals mass times the Hg minus Hf. Think about, because when you become saturated vapor from saturated liquid, you got to absorb heat. Where does the heat come from? You extract the heat from your food in the refrigeration chamber. So that's your QL, because the heat released from the chamber, it's called QL. So that's the question here. So that's all for this question. I accidentally erased this part. Okay, so that's the question. If you have any question, you can comment or email me or leave a message in room.